In this video, I'm going to talk about interleaved tables in CockroachDB. I'm going to talk about what an interleaved table is, how it works under the hood, and why you'd want to use it in your application. So to start off, an interleaved table is basically a way of teaching the database a little bit more about your desired physical layout of your data on disk. You can use an interleaved table if you want to make sure that when you're scanning two parts of a table that are related to each other by a join key, you can guarantee with interleaved tables that the data that you're trying to join together will be co-located on disk. So it's a bit tricky to visualize, so I'm going to get into an example. I'm going to open my Cockroach demo shell for this. And for this example, I wanted to do a kind of songs table and a plays table. So we're going to pretend to be maybe some kind of streaming audio service or something like that. So to start off, we're going to make a songs table. Create table songs, song ID int primary key. We're going to maybe give it an artist string and we'll give a song string and an artist string. So name string, artist string, like this. We'll insert some songs into our table. Insert into songs values. So our 0th song will be Rascal by the artist RMR. And the second song will be Help by the Beatles, just as our very simple and basic music library. So now we're going to try to make another table, which is our plays table. And this is going to represent all the times that anybody played a particular song. So we'll make a new table, create table plays, and we'll give it the song ID again. So this is to link it back with the song that was being played, song ID int. We'll give it a play ID int, and we'll give it a listened at timestamp. So this is the time that the user actually listened to the song. And as the primary key, we're going to give it a composite key. We're going to give it the song ID first and then the play ID second. And the reason for this is that we want to make sure that every single maybe you wanted to make sure that the play IDs are per song instead of global. So we'll give primary key song ID comma play ID. And I guess we could also, for good measure, we could make a foreign key relationship between the song ID part and the songs table itself, just to make sure that there's always going to be a song in the songs table for a given play. So we'll say references songs song ID. So here's our plays table, and we'll insert some plays into it. So we'll insert into plays values. So the song ID will be 0. So we're listening to Rascal by RMR. The play ID will be 0, so this is the first time somebody listened to it, and then the listened at timestamp will be now. And we'll insert another one of those, so somebody listened to Rascal shortly after that first play. And then the third thing is that let's give a play of Help by the Beatles. So we can give this we'll start over from 0 for the ID of this play. So let's go ahead and check our data. Select star from songs. We'll see our 2 songs here, and select star from plays. We'll see our 3 plays here. And so let's say in our application, it's a common operation to try to figure out all of the plays for a given song, along with the song information. So as an example, let's try to select all of the plays for song ID 0, along with some of the information about song ID 0. So maybe the name of the song. So we could say select name, comma, listened at. Maybe we'll ask for the name, the play ID, and the listened at. Play ID listened at from songs join plays on songs.song ID equals plays.song ID. And then we'll constrain it where song ID equals 0. Of course, we've got to disambiguate our reference here. So this is going to be all of the plays for this particular song, so Rascal by RMR. This is all great, and this of course will work, but it may be the case that you want to make your schema as efficient as humanly possible. And the truth is that this is not as efficient as humanly possible, given the fact that we aren't using interleaved tables for it. So I'm going to draw a quick little picture to try to demonstrate the physical layout of the table that we're looking at right now. So we'll go over here. And so our songs table is going to be up here. And it's like a big, chunk of data on disk here. And then somewhere else on disk, so we'll use a different color. Somewhere else on disk, we have our plays table. And if I wanted to join these two tables together, even if I constrain some of the data, and remember that in our particular example, both of these tables are keyed first by the song ID. So maybe let's put some IDs in here as well. So maybe we'll have sort of ID 1 here and ID 2 here. Actually, I'm actually going to give 2 a different color for the purposes of some illustration. So we'll give this the green color here. Song 1 is over here, song 2 is over here. And in our plays table, it's going to be the same thing. We're going to have a couple of plays for 2. Maybe, I think in this case we just had 1, but you can imagine that you might have 2 plays for the second song, as well as 2 plays for the first song, like this. And so let's say in our query we wanted to say, give me all of the plays for this song 1. What we actually have to do to join these two things together is we have to scan 2 parts of the disk. We've got to scan once here to try to get all of the songs with ID 1. And then we've got to scan twice over here in the plays table to get all of the plays with song ID 1. So that's 2 scans. Maybe we want to do better. And let me show you actually also in the terminal how you can prove to yourself that it was in fact 2 scans. To do this, we can use this tool Autotrace that we looked at last time in the column families video, which will be linked above. And so let's do the same thing here. We're going to say set Autotrace equals on comma kv. So this is going to give us all of the kv operations that the SQL query is going to emit in the system. And we'll run this join again. So there's going to be a lot here, but there's 2 things going on that I wanted to point out. One is this first scan, and the other is the second scan. And the point is that we're doing 2 scans, just like I was trying to show in that picture. We're scanning the first table to get all of the songs with ID 1, and we're scanning the second table to get all of the plays with song ID 1. Now with interleaved tables, we can do better. We can make it so that the plays are actually co-located with the songs that they're related to. And given that co-location, you will only have to do 1 scan, which is a more efficient way of retrieving data if you can do it. So how do we actually get that to work in CockroachDB? What we're going to do is we're going to make a different table definition. So I'm going to, just for the purposes of keeping things simple, I'm going to copy this table definition and edit it a little bit. So we have create table plays, and now I'm going to call this one create table plays 2, maybe just to keep track of that there are 2 tables, one's interleaved, one isn't. And I'm going to add this extra clause here at the end, which says interleave into parent, and I'm going to interleave it into the songs table, or the songs parent. And we're going to interleave it on the song ID column. Interleave in parent, not into parent. Okay, and of course we had our auto trace on, so it was unintelligible. Let's just go ahead and turn that off and do it again. So we'll drop table plays 2, and we'll just do this again without auto trace on. So we have our second table here. Now, if we insert the same data into plays 2, let's just do that. So we'll say insert into plays 2, select star from plays. So this should copy all of the data from plays into plays 2. And then let's look at plays 2 just to make sure it's looking okay. It's looking okay. So now if we run our join again, of course these tables are logically the same. So hopefully the join will actually produce the same result. So we're going to change plays to plays 2 everywhere. Great. So the result is the same, which is that we have 2 plays of RMR Rascal. But the big difference is that under the hood, and we can look at this with our Autotrace tool again, set Autotrace equals on comma kv, is that hopefully we'll only see a single scan. And so in fact, we did only see a single scan. And we see something else that's special, which is something called interleaved reader joiner, which I'll get into in a second. But so how is it possible that we can only do one scan here, given the fact that we're touching two tables at the same time? Well, I'll try to draw a picture to illustrate. So in this example, we kind of had these two tables and they're living in completely different spots on disk. With interleaved tables, we're going to actually do something a little bit tricky. So I'll just draw a line here and I'll redo our songs table in sort of the new world. So we'll still have a songs table and it'll still have all of the data that it has above. The difference is that we're actually going to have some spaces in between each of these entries here. So we'll have our first song here, but in between the first song information and the second song information, which I'll draw again down here, we actually are going to have all of the plays that are related to this particular song. So we'll have all of these plays over here. And let's actually, since we didn't write any data into our plays table, it's a bit hard to see. So I'll add some data into our plays table. So this is maybe our listened at timestamp. So we'll say this was at T1 and this was at T2. So down here in our interleaved version, we've got the songs table, and then also interleaved in between these two songs rows, we also have plays rows. And the plays rows have exactly the same data as they did before. So they sort of have this T1 thing going on here as separate rows in between the rows of the songs table. This should be T1, not T2. And this is T2 here. And of course, if there was more data in the plays table, there would be more data in each of these rows here. And it's the same with the plays down here for song number 2. If we had written them, we would have had, T3 and T4 or something like that. So this is actually super, super cool because it does let you say on disk, even though there's two tables here, we're actually merging these two tables together into a single physical location so that when we want to get all the data for song 1 from both the songs table and the plays table, we only have to do a single scan and it's over this range of the table right here. And so that's exactly what's going on in our example here. And this is exactly why we only produced one scan line. It's because we're only scanning the physical location that's given by the songs table, even though there's extra rows inside of there. There's the plays rows as well. And so I was gonna explain what this guy is, this interleaved reader joiner thing. What this is it's a special operator within CockroachDB that knows how to operate upon rows from more than one table at a time. Since if you're the ordinary way of scanning data in CockroachDB only really understands rows from a single table at once. So in this example for songs, you'd be looking at first this row number 1 here, and you'd be looking at first then this row number 2 over here. This interleaved reader joiner thing, it actually is a little bit smarter, and it knows that this songs table actually also has interleaved within it this plays table. So that's why that thing is called interleaved reader joiner. And I think you can also see it if you looked at the explain dist SQL graph here, and you pop this open into your browser, you can actually see that we are doing this special interleaved reading thing where we're looking at both the songs table and the plays 2 table at once. Yeah, so that's basically what I wanted to cover. I tried to show what interleaved tables were, why they're good. I guess I didn't really get to why they're good. The reason that you might want to use them again is for some reason you think that your application is too slow because it's doing these 2 scans, and you want to make sure that it's just using 1 scan. So it's really about extracting the maximum performance out of your database in this particular use case. I suppose I should mention, one downside of interleaved tables, which is that something will happen a little bit worse in certain cases. And what that is if I wanted to scan, instead of, say I didn't care at all about the plays table in my query. So in my example, I wanted to just do select star from songs, ignoring the trace information down here again. Of course, we're going to get the same result, but under the hood, the database is actually going to have to scan over way more data. It's going to have to look at this, an actual song row, and then it's going to have to skip a play row, skip another play row, then come back to a songs row. So if you want to do a lot of global scans over the parent of an interleaved relationship, it's going to be less efficient. But that may be okay in your use case, depending on what you're looking to do. Yeah, so that's pretty much all I had to say. Interleaved tables are pretty cool, good for trying to extract performance out of your database. They're all about changing the physical location of your data on disk. And with that, I think I'm going to sign off. But if you do have any questions, feel free to leave them in the comments or tweet me at Jordan A. Lewis on Twitter, and I'm happy to answer them. If you have other ideas for videos like this, I'm also looking for new things to talk about. Schema design in CockroachDB, it's sort of fun to talk about, and I'm happy to do a video on it. So please, hit me up in the comments or on Twitter, and I'll try to do my best there. So thanks a lot for watching.